So we're doing OCRs, paper 5, the higher tier maths paper, no calculator, from November 2019. And if we just have a look at grade boundaries, paper 5, you need 22 marks for a 4, 32 for a 5, all the way up to 81 marks for a grade 9 on this paper. So question 1, and we're going to add 3/4 to 1/6, and if you're ever adding fractions, you're going to need common denominators. Fastest way to do that, multiply those together. 4 times 6 is 24, so we're going to work in 24ths. I multiplied this by 6, so this gets multiplied by 6, and 3 6s are 18. And I multiplied this by 4, so this gets multiplied by 4. What you've got is 18 24ths added to 4 24ths, and that is 22 24ths. Be careful, it does say simplest form, so we'll just start by halving top and bottom, and we get 11 12ths. 11 is prime, so there's your final answer. Part B says, write each number to one significant figure and use estimation to show that this comes to about 80. Well, one significant figure rounding, 39.6 becomes 40, 20.2 becomes 20, and 99.2 would become 100, and then we're going to do the square root of 100, which is 10. So we've got 40 times 20 divided by 10. 4 times 2 is 8. There's going to be 2 zeros on the end, and we're going to divide by 10, and 800 divided by 10 is 80 divided by 1, which is 80. Question 2, we've got 168 written as a product of prime factors, and then we're asked to find the lowest common multiple of 168 and 30. Well, if I firstly write 30 as a product of prime factors, 30 is 2 times 15, and 2 is prime. 15 is 3 times 5, and they're both prime. So 30 is 2 times 3 times 5. The fact that we've got prime factors is suggesting we're going to use a Venn diagram to do this. So I'm going to draw a Venn diagram. Over here I've got 168, and over here I've got 30, the two numbers that I'm dealing with. And for the lowest common multiple, I need all of this filled in. So let's work through this steadily. 168 is 2 times 2 times 2, that's the 2 cubed, times 3 times 7. These share a 2 as a factor. They share a 3 as a factor. And then there's no other shared factors. So we've got a 2, and a 7 left in the 168 side. And then just a 5 left in the 30 side. And for lowest common multiple, I need to multiply all of this together. So 2 2s are 4. Times 2 again is 8. 8 times 3 is 24. So I need to do 24 times 5 times 7. But this would be the same as 120 multiplied by 7. 7 notes are, no, 7 2s are 14. 7 1s are 7. The answer is 840. Question 3, we've got a page of algebra that someone's done, and we've just got to find the error. So question 1, we've got 2a times a times a. Well, a times a times a is a cubed, and we've got 2 lots of that. So the correct answer is 2a cubed, and the error here is that she added when she should have multiplied. 2a add a is 4a. Question 2, we've got x to the power of 10 divided by x squared. These are your laws of indices. We need to do 10 take away 2. So you get x to the power of 8. And the error here, she divided these indices when she should have taken them away. And then part C, we've got some substitution. So we can see the numbers have been put incorrectly. U is 0, T is 5, and all the way through the numbers are incorrectly. But if you look at this bit here, she's done a half times 6 times 5. 6 5s are 30, and a half of that is 15. So here she's done the multiplication when really she should have done 5 squared first. And that's the error. She should have squared before multiplication, just following BIDMAS. The correct answer, well, we're going to do 0 times 5 added to a half times 6 times 5 squared, 25. 0 times 5 is 0, so that's gone away. we've got to do a half times 6, which is 3, and 3 times 25 is 75. Question 4, and here we've got a chocolate bar that was 250 grams, and it's now been reduced to 220 grams, and we want the percentage decrease. Well, let's find the decrease first. 250, take 220, it's gone down by 30 grams. For percentage change, we want the change divided by the original, and it originally weighed 250, and then we're going to multiply that by 100 to change to a percentage. 30 divided by 250, well, that's the same as 3 divided by 25. Now, I might not want to do 3 divided by 25. Instead, to get this to a percentage, I can get rid of that and just times top and bottom by 4. What I'll get then is something out of 100, and that straight away is my percentage. 3 times 4 is 12. 12 over 100 is 12%. So this is a 12% decrease. Question 5, we're asked to solve an equation with x's on both sides. If you ever get this, always get rid of your smaller x's first. So let's take 4x from both sides. And 6x take 4x is 2x. That's gone away, and we're left with the plus 1. Let's now add 10 to both sides. And we end up with 2x equals 1 add 10 is 11. And final step, divide both sides by 2. And what you're left with is 1x equals 11 over 2. There's no need to go decimal here. 11 over 2 is the correct answer. If you insist, then that's 5.5. Question 6, and we've got a nice quadratic. We're told to solve by factorising. So factorising a quadratic, we're going to put it into 2 brackets. There's an x in each bracket, and we're looking for 2 numbers that add to 9 times to 20. Those are 4 and 5. 4 and 5 is 9. 4 times 5 is 20. Remember, when we're solving, we need to reverse the sign of these numbers in the bracket. So x is minus 4 and x is minus 5. We've got 2 ratios. So we've got Sundip starts with 3 parts and ends with 2 parts. And then we've got Emma starting with 5 parts, and Emma finishes with 3 parts. So what I'm going to do is try and combine these 2 ratios, or get them to match at least. If I take this first ratio and multiply it by 2, okay, then what we get is Sundip to Emma. Double this and double this is 6 to 10. And then if we look at this second ratio and multiply by 3, then we get Sundip and Emma is 6 to 9. And what I've done is got Sundip's parts to match because he doesn't lose any money. Okay, so he stays at 6 parts here. I've just found a common multiple of 3 and 2. But what we can see here is that Emma goes from 10 parts to 9 part. So Emma loses 1 part, and she also loses £450. So that 1 part there is £450. The actual question says, how much does Sundip have? Well, he's got 6 parts, so we need to do 6 lots of 450. And I'm just going to do that up here. This is a non-calculator paper. 6 noughts are nought. 6 fives are 30. 6 fours are 24. With the 3, that's 27. Sundip has £2,700. Question 8, and what we've got is some information about a diagram. And what we're told is AFE, so A to F to E, and CEF, CEF are equilateral triangles. And what that means is all of those sides are the same length. And then it says, what's the mathematical name for AFCE? AFCE, well, that's a four-sided shape where all the sides are the same. That's a rhombus. It's not a square, it's a pushed over square. Part B says the ratio of angle DAE, so this angle, to EAF, that angle is 1 to 4. Well, we know the green angle, EAF, is 60 because that's an equilateral triangle. So if this is 60, then this one must be 60 divided by 4, which is 15. 1 to 4 as a ratio is the same as 15 to 60. So that angle there is 15. That means that angle there is 15. And what we can actually say is, what is this entire angle? Well, all of that would be 60, add 15, add 15, which is 90 degrees. Going back into a shape, we already know that this down here is an equilateral triangle. So that would also be 60. 60, 60, 60 makes the 180. Now we've got a four-sided shape where we know the top and bottom angles. So what I'm going to do is 60 add 90. That equals 150. For a chi, these two angles must be the same. And because this is a four-sided shape, they all add up to 360. So I'm going to do 360. Take away this 150, which is 210. And then because there's two of these angles and they're both the same, I'm going to do 210 divided by 2, and that is 105. Question 9, and we've got a scale of 1 centimetre is 25 metres. And we want that in the form 1 to k. Problem straight away, we've not got matching units. So I'm going to change 25 metres into centimetres. There is 100 centimetres in every metre. So I'm just times this by 100 and you get 2500 or 2500 centimetres. And what we've got now is 1 centimetre to 2500 centimetres. They're matching units. K is 2500. Part B is a scale drawing or a constructions question, which is going to be absolutely disgusting for me to do on this device I'm working on, but I'll try my best. What I'm going to do first is this first line. The boat leaves the harbour from point C. So we're leaving from here and sails on a path that is equidistant from BC, this line, and CD, this line. So when you've got something that's equidistant from two lines, what you're looking for is called the angle bisector. So you're going to need to cut that angle in half. Now you would need to do this properly with a pair of compasses. So what I'd need to see on an exam is your compass opened and placed on C. We need an arc all the way around like this. You then need to move your compass point to here, and you'd draw some kind of arc like that. You'd move your compass point to here without changing it and draw some kind of compass point like that. And then you'd connect C to this cross here. So that's what we need to see on a real exam. The next bit says the harbour rules do not allow the boat to sail within 75 metres of E. This point, well, we've got a scale here that says 1 centimetre is 25 metres. So 75 metres would be 3 centimetres. So what you need to do is, again, grab your compass, open it out to 3 centimetres and draw a circle with a radius of 3 centimetres. And the question says, by using construction, is the boat following the harbour's rules? Well, if it follows this line, it's going to enter that no-go zone. So I'm guessing the answer is no. Question 10, we've got some information about people on a plane, and it says 2/5 were British, and then it says 30% of the British were men. So I'm just going to write that down, 30% of the British, but wait a minute, 2/5 are British. So I'm going to say 30% of 2/5, they are the British men. If 2/5 are British and 30% of the British are men, 30% of 2/5 are British men. What we've got here is a multiplying fractions question. 30% is 30 out of 100. Well, that's the same as 3 out of 10. Of can be seen as a multiply, and 2/5 is just 2/5. So I've got 3/10 of 2/5. 3 times 2 is 6, and 10 times 5 is 50. So 6/50ths are the British men. We're told that there are 36 British men, so 6/50ths is those 36. Well, 6/50ths is the same as 3/25ths, and that's still 36. I've just simplified my fraction a little bit. If I want to know total number of people, I need 25 25ths. So first I'm going to work out 1/25th, and I'm just going to take this number and divide it by 3. If 3/25ths is 36, 1/25th must be 12. And if I know 1/25th, I can work out 25 25ths. I just need to do 25 times 12. Well, 12 times 25. Well, 10 times 25 is 250. And 2 times 25 is 50. And if you add those together, you get 12 25s, which is 300. Question 11 is saying you've got 100 pencils that are either red or green, and it wants a method to estimate the number of pencils without looking and by only picking one pencil at a time. So what you could do is the following. You could pick a pencil and record the colour. You could do that 10 times. 3 red out of 10. And you're going to do this 100 times. Then you would just do 3/10 multiplied by 100, and that would give you 30 pencils. This is called relative frequency. You're doing an experiment, you're recording the probability from your experiment. So this is an example. If you've got 3 red out of 10 in total, then you're going to say that 3/10 are red, and if there's 100 altogether, 3/10 of 100 is 30. Question 12, we've got a box plot, and we just asked for the interquartile range. Well, for interquartile range, we need your upper quartile, which is that measurement, and we'll just use the scale. It is going up in ones by the looks of things, so that's 64. You also need your lower quartile, which is that measurement. And again, just reading from the scale, that's 49. And we're going to do 64 take away 49, and 64 take away 49 is 15. There's your interquartile range. Part B, we've got information about the girls' test scores, and we'll have to draw a box plot. Well, median is the middle of the box plot, so 55, 6, 7, 8. That's going to be there. The lowest mark is 32, so 31, 2, right there. The upper quartile is the thing I'm going to do next, which is 66. So 65, 66 is there. And I've done that first because I don't know my lower quartile and I don't know my biggest score. They're the two things missing. So they've given this isn't kind of like a puzzle. What I do know is my interquartile range is 12. And from this question, the interquartile range is the width of this box. So I've got my upper quartile. I know the width of my box is going to be 12. So I need to do 66, take away 12, and that will give me the lower quartile. 66 take 12 is 54. So my lower quartile is 51, 2, 3, 54. And then finally, I'm going to do a similar thing, but for the range. The range is 44, and the range, remember, is your biggest, take away your smallest. So I know my smallest is 32. My range is 44, so I need to do 32 added to 44, and that's going to give me my biggest value. 32 add 44 is 76. 75, 76 would be here. And if I just connect these together, there's my middle box. And there's the rest of my diagram. Part C, my mate Eleanor says the boys did better because they had a bigger interquartile range. Remember, interquartile range is how far apart this box is. Is she correct? Explain your reasoning. The answer is no. The interquartile range only shows how consistent they were. So if boys had a bigger interquartile range, they were actually less consistent. If you're going to say who's better, you need to look at the median. Okay, so I'll write that down as well. If my mate Eleanor had said the boys are better because they've got a higher median, then she would be correct. Question 13, we've got to write 1/3 as a decimal. Well, 1/3, if you don't know, is 1 divided by 3. So that's how many 3's into 1, and the answer is 0. Decimals is what we're going to need and some digits to work with. 3's into 1 is actually 0 remainder 1. 3's into 10, 3, 6, 9. 3 remainder 1, 3's into 10. 3 remainder 1. You've got 0.3. Recurring. Part 2 is 1/30th as a recurring decimal. Well, 1/30th is 10 times smaller than 1/3. So I'm going to need to divide this by 10. And that's going to move all your digits to the right. So you're going to get 0.0333. Part B, we've got to rationalise the denominator of this fraction. So we've got 20 over root 5. Just knowing how to rationalise the denominator, we need to times top and bottom by that root 5. And what you get on top is 20 times root 5 is just 20 root 5's. And root 5 times root 5 is 5. And then we're just going to simplify this down. 20 over 5. 20 divided by 5 is 4. So you're left with 4 root 5. Question 14, y is inversely proportional to the square root of x. So what we need to do first is write that using algebra or using mathematical symbols. And we get y equals inverse proportion is k over, and it says square root of x. Not y equals kx. That would be direct proportion. Inverse proportion is k over. And that's a square root of x. We can substitute these numbers into that. So y is 7. We get 7 equals k over the square root of x is 25. And we can work out k by doing, that's the same as 7 equals k over 5. Something divided by 5 is 7, or 7 5s are 35. So k equals 35. Just working out what k is there. We can then write a formula. So I'm going to take this, and and just write myself a formula that says y equals, not k anymore, but 35 divided by the square root of x. And I can use that formula to find y when x is 100. Y is 35 divided by the square root of 100. Square root of 100 is 10. 35 divided by 10 is 3.5. Question 15. Here we've got some transformations to do. So I'm just going to follow these transformations and see what happens. First one, we've got a translation of -7 minus 2. Well, that's 7 left and 2 up. Left and right at the top, up and down at the bottom. So I'm going to go 7 left. 1, 2, 3, 4, 5, 6, 7. And then 2 up, 1, 2. And then I'm going to follow on with this translation. That's 3 to the right and 5 down. 1, 2, 3 to the right and 1, 2, 3, 4, 5 down. If I draw this triangle, remember it was the top corner that I moved. It's going to go across there and there like that. And the only way to get from there to there is another translation. And I just need the vector that moves me from here to here. So I'm going to just count again. 1, 2, 3, 4 to the left. And 1, 2, 3 down. So that's 4 to the left and 3 down. Part B says reflecting the line y equals x and then rotate. Well, I'll do the reflection first. So I'm just going to clear this original off. Here is y equals x. Just that straight diagonal line. And I might use tracing paper or I might just count across. So I'm just going to pick each corner, count to the mirror line. That's 1, well, that's half a square to the mirror line and half a square on the other side. Pick this point and again just going diagonal. 1 and a half, half and 1. And what you're going to get is a reflection like that. So that's that done. And then it says rotate 90 degrees clockwise about 0, 0. So 90 degrees clockwise around 0, 0. So I need to spin this a quarter of a turn. And if I do that, I believe it's going to land there. You would do that with tracing paper. You'd trace your shape, you'd place your pencil on 0, 0, and you'd spin a full quarter turn. And I'm pretty sure that's where it lands. So how do we get from there to there? Well, it looks to me like we've done a reflection. The shape has flipped over, if you like. And the line that we've flipped over is this one smack bang in the middle of these two shapes. And that is the x-axis. You could say about y equals 0. Question 16, we've got 50 people doing something outdoor. There are 40 who walk. There are 18 who sail. And 3 people did neither. When you've got one activity, another activity, or nothing, to me that's screaming Venn diagram. So I'm going to draw myself a Venn diagram. We've got walking over here, sailing over here. The middle would be both, and the outside is neither. So the problem with this Venn diagram, I've got 40, add 18, that's 58. And then 3 more makes 61. So this is 61 people. There should only be 50. So that there is 11 too many. And if ever you've got information for a Venn diagram, there's too many people, your too many people goes in the middle. What we can do now is adjust these numbers. 40 people walk. Well, this is all of my walking people. I need 40 in there. I've got 11 already. This must be 29. 29 and 11 makes the 40. If I look at my sailing people, this is sailing. I need 18 in there altogether. I've already got 11. That must be 7. And then the outside bit is 3 people. We can double check. 7 add 3 is 10. That would be 21. 30. That's now 50 people. That's correct. Once the Venn diagram is completed, it says one of the people who walked is chosen at random. So the minute we're told that this person walks, that's the people I'm looking for. I'm only interested now in the people who walk. So it's going to be out of 40. It says, what's the probability that they also sailed? Well, also sailed is in the middle. It's 11 out of 40. Question 17, we've got some difficult indices work to do. So we need to just know several things to start with. We've got a to the 4 there, and we're cube rooting that. Now, cube rooting is the same as raising to the power of a third. So rather than write cube root, I've raised to the power of a third. So that's all of that bit changed, if you like. And I'm going to multiply by 1 over a. Well, 1 over a is the same as a to the minus 1. So I've just changed the form of some of these things. What we can do now is start to simplify this, just using as normal laws of indices. A to the 4 raised to the power of a third. Multiply those together. You get a to the 4 thirds. We're going to still multiply that by a to the minus 1. And then again, this is your normal laws of indices. When you're multiplying indices together, we add these powers. So I'm going to do 4 thirds, take away 1. 4 thirds add minus 1 is 4 thirds take away 1. Well, 4 thirds is 1 and a third. And I'm going to take away the 1. So that's a to the power of a third, just like we were told. Question 18, we've got a straight line graph has been drawn. And if you look at this, 3y add 6x equals 13. That's very much 3y add 6x is greater than or equal to 13. That's the same thing, just with an inequality rather than an equal sign. It then says draw 2 more lines to find a region. So these are the lines I need to draw. I've got y equals x minus 2. So if we draw that one first, just open up a table, choose some x values. We'll do 2, 3, and 4. And y will be x take 2. So x take 2 becomes 0, x take 2 becomes 1, and x takes 2 becomes 2. These are my coordinates. I'm going to go across to 2 and up to 0, across to 3 and up to 1, and across to 4 and up to 2. Just check my inequality. I have got an or equals, so that means I need a solid line when drawing that straight line. The next line we're looking at, well, we've got x is greater than 3. So I just need to draw x equals 3. There's my x-axis. There's 3. And x equals 3 will be straight up and down. Just again, checking my inequality. There's no or equals sign there. So I'd need a dashed line. Now I've zoomed in a little bit on this question. 1, because I messed up, and 2, because it gives us a bit more space to work with. Usually when you've got a question like this, you'll find a triangle in the middle, and that's the region you're looking for. But when we drew x equals 3, the original inequality was x is greater than 3. And if you think about where x is, we drew x equals 3. This way is all the values where x is greater than 3. So my inequality can't be this region, because that's going to be x is less than 3. So the region that satisfies x is greater than 3 is coming this way. Remember, we want a region that satisfies all 3 inequalities. There's only one zone here that satisfies 3 separate things, and it's going to be that bit there. You can double check the red line. The original inequality was y is less than or equal to x minus 2. Just pick a point in this region. Let's say that one. That's the point 4, 1. And we just want to check, does the y value 1, is that less than or equal to the x value 4 take 2, is 1 less than 2? The answer is yes. So that point is right. And that's going to mean that this is definitely the region that I'm looking for. Question 19, we just asked for the value of sine 45. Well, sine of 45 is just 1 over root 2. That might end up coming back later in this question. Part B, all this information is just this diagram, except for that. That's giving us a hint at something we might use later, I think. It says work out the length of BC. Well, when you've got two triangles drawn together, 9 times out of 10 you need to find this side connecting them first. So I'm just going to work on this blue triangle. I'm going to sketch it out separately. We're looking for that. We know that this is 10 root 6 and this is 30 degrees. Trigonometry, that's the opposite. This would be the hypotenuse, so that's the adjacent. This is an opposite adjacent question. Just write so, ka, toa, opposite adjacent is there, and this was a hint that we're looking at a tangent question. So I'm going to write tan theta equals opposite over adjacent. Start substituting. Tan 30 equals the thing I'm looking for, question mark, over 10 root 6. And then the question mark, just multiply both sides by 10 root 6. We're going to get question mark equals tan 30 multiplied by 10 root 6. We're told in the question that tan 30 is 1 over root 3. So question mark is 1 over root 3 multiplied by 10 root 6. And that's going to be the same as 1 times 10 root 6, which is just 10 root 6 over root 3. 1 times 10 root 6 is 10 root 6, and the root 3 just stays on the bottom. Root 6 divided by root 3 is root 2. So that will simplify down to root 2, and you end up with 10 root 2. So now I'm going to work on this green triangle. I've not left myself much room, but I'll just sketch it out, just rotate it around a little bit. I know that that side is 10 root 2, and it says here that BC is CD. So these two sides are the same. And what we can use now is Pythagoras' theorem. If I call that A, that B, and that C, then A squared plus B squared equals C squared. If these are both the same, I can call them both X. So you get X squared plus X squared. You get 2X squared. And we know that C is 10 root 2. So I'm going to do 10 root 2 squared. I can work this out, and I'm going to get 2x squared equals 10 squared is 100, and root 2 squared is just 2. So this becomes 100 times 2, which is 200. This is actually working out really nice again. Sorry, I've not left myself much room. If 2x squared is 200, then x squared is 100. And that must mean that x is 10. The square root of 100 is 10. Question 20, we've got a quadratic and we're asked to put it in this form, which is just completed square form. Single bracket squared is completed square form. So we're going to open up some brackets and square them. We're going to put an x in there. This minus 6 gets halved to minus 3. I'm going to take this and square it. Minus 3 times minus 3 is 9. And we always take that away. And then don't forget this plus 11 is just bolted on the end. We can tidy that up a bit. X minus 3 all squared minus 9 plus 11 is plus 2. So that now is completed square form. Moving down onto part B, we're asked to sketch this same graph showing any coordinates of any turning points. Well, when you've completed the square, you get something called the turning point. It's a coordinate. You reverse the sign of this -3 in the bracket, so that becomes +3. And then this thing on the end stays as it is. So that's still a +2. So my turning point across to 3 and up to 2 is roughly there. It doesn't have to be exact. We've got something else in this quadratic, which is the 11 on the end. What that is your y-intercept. And then because this is a positive x² graph, we're going to have a U-shape. So all we've got to do is come down through 11, hit the turning point, and then go back up as a U-shape. Final question on this paper, question 21. We just need to know about the equation of a circle. Well, every circle has the equation x² plus y² equals the radius squared. The radius squared is 36, so the radius must be the square root of that, which is 6. And we've just got a standard x² plus y² circle that will always go through the centre, note, note. If we look at part B, we've got 2 points, but I'm just going to focus on one of them. This is an x, y coordinate. So I'm going to start with my equation of a circle, x² plus y² equals 36 in this case. I don't know the a coordinate, so that's going to stay as x². I do know the y coordinate, so this is √11, and I need to square that, equals 36. I can work this out. x² plus √11 squared is just 11. And that's 36. And then if I take 11 from both sides, x², 36 take 11 is 25. So x must be both the positive square root of 25 and the negative square root of 25, both of which are 5. So what I've got here by working this out is not only the a, but the b. Okay, what I'm saying here, if I draw that circle, I could go across to 5 and up to √11, or across to -5 and up to √11, and they would be both points on that circle. And it'd cross at 6, 6, and -6, the radius of the circle. So I've actually found both using one bit of substitution. Be careful, it does say work out the length between those points. Well, if it goes from +5 to -5, the distance is 10.